So let's talk real quick about the Lab 6 that you guys will get started on this afternoon. And like I said, don't stress too much if you're still working on Lab 4 or even Lab 2. Really just, get as far as you can in these, and all of these resources will still be here at any point. And Friday, you have like all afternoon to get caught back up. So what have you guys done so far? So Lab 2, or at least in the even labs. Lab 2, you created a new Git branch, and you had your new pilot app that loads in a pose, scores the pose. You had a Monte Carlo loop. You could look at those in PyMol and do packing and minimization. So for Lab 4, you're analyzing those acceptance and rejection rates. You're looking at these structures. You wrote some unit tests, you created a fold tree, and then you're going to use those functions in your protocol. So for this lab, we're going to work on creating a new mover subclass. So we've had a lot of presentations today that kind of build up to this point. You're going to connect that mover to the MoverFactory, add the private data members for your MyMover class, and then hook that into RosettaScripts and actually use your mover in a Rosetta script. So how are we going to do that? So when you're creating a class in Rosetta, just kind of the coding conventions, because as you write your mover class, so bootcamp mover or whatever you call it, there's some conventions to follow. So in Rosetta, all classes are named in camel case. So if your class is bootcamp mover, then the B, C, and M would be capital. The namespaces match the directory hierarchy, which we've kind of talked about. That should be true for everything. And every class requires 3 files. So it should have a forward header file, your regular header file, and then your CC file. And then the creator class. And your header files will have include guards. Will include guards. And they must not include public data. So fortunately, there are code template generators to generate all of these files for you, and then you'll just kind of fill them out. So what do those look like? So there's for making your mover files, you have the generate templates.py. You would say that the type is a mover, give it the name of your class, and a brief kind of description, and what the namespace should be. And then there's also, I can't remember if that was in your last lab, but there's also a template generator for unit test. So you would give it the similar information. All right, what about in PyRosetta? So PyRosetta also has coding conventions. So I did mention there is a link on the Rosetta the Rosetta documentation for the C++ coding conventions, and then there's also a link for the PyRosetta coding conventions. So your class name should still be in camel case and end in mover. So for the namespacing, you'll use bootcamp_mover. And there is no code template generator to create these files in PyRosetta. Maybe that's something one of you would like to write. But I mean, you have a little bit more flexibility, so you don't have to have you need to have all those classes we talked about, but you don't necessarily have to have them in different files or in a specific way, organized in a specific file way. So we talked about this a little bit this morning, but just to kind of remind you, so if you think we have, you're making bootcamp mover will inherit from the mover class, and you'll also have your bootcamp mover creator, which inherits from the mover creator class, and these will be, so your bootcamp mover will be defined with the forward header file, the header file, and the CC file. And then you have your bootcamp mover creator header file. And these are kind of how the mover registrator gets connected to your creators through the MoverFactory, which we talked about. So what's in your forward header file? So this is going to be for the C++ folks. You'll have your copyright line, which you should have seen already and seen in some of the files. Does this look familiar? Yeah. You'll have your your Doxygen information or documentation. So these comment lines with the 3 slashes and at. So you'll have the file name, a brief description, the author. Is the author pre-filled out when you run your template generator?
I think so, with the template generator.
Yeah, so if you have your template generator, that information should be on there. I would just double check that that's up to date. Maybe if your GitHub was, I don't know, had like a weird email address that you don't check. And then you'll also have, like, this is another Doxygen comment. Also for your forward header, you're going to have include guards to make sure that you don't have any like circular inclusions where if this is already included, then it doesn't get that again. So you have these if in def, your pound defined, and then the in diff. So that should all be in your forward header. You have your includes, and you're going to use so you'll have your owning pointer header file here, and then you'll define like your type of your mover, the owning pointer of your mover. So you have an owning pointer and then the const owning pointer. For your header file, once again, you'll have very similar lines. So you're going to have your copyright. So all of the files, all of your code files that you're adding to Rosetta should have the copyright lines. And then again, you want to have the Doxygen lines. And then you'll have the headers that you include in your header file. So most of the headers that you'll include in your header file are going to be the forward headers, except for your inheriting from mover for your mover header file. And then the types, core types, they don't have forward header files, so those are defined just in the header files there. So for your header, like I said, your mover is going to inherit from mover, and then you'll have kind of your boilerplate methods or your standard methods of your constructor. You'll have your destructor, and you can overload your constructor depending on what inputs you have for that. And then we've talked about this several times, but just to remind you, there are virtual methods in the mover class, and there are 2 of these that are pure virtual or abstract. So you'll need to define your apply function and also your get name function. There are other functions in the mover class that are not pure virtual, but virtual that you can override. One of those is the parse my tag, which we will talk about more, and that's important for making this compatible with XML or for RosettaScripts. And then also in your header file, you'll have your private data, and then you might have other functions that you need to define to access your data that you'll use in your mover. And then for your CC file, you'll have once again the copyright. Oh no, sorry, this isn't for that. This is for Python. I should have known, my little icon. So for the PyRosetta stuff, this is a little bit fuzzy, but you can include, if you're putting scripts into the PyRosetta repository, you might choose to include the copyright header. This isn't necessary. It's really, if you put it in there, then if you have your script in the PyRosetta scripts repository, then it kind of is being distributed by Rosetta, so it would fall under the Rosetta license. But if someone is running PyRosetta already, so this has really confused me. I've asked Rocco about it a lot. But if someone is already able to run PyRosetta, then they already have a license for, like, they already have a Rosetta license. So your script having this copyright header would not like limit anyone from using your PyRosetta script unless like your script didn't have any PyRosetta in it. But then I don't know why you're putting in the PyRosetta scripts repository. But does that make sense for people? So even if you don't have this header on there, like we're not gonna like hunt you down and be like, you have to put this header. But it's still gonna be under the Rosetta license if it's in the PyRosetta scripts repository. But you would need a license anyways to run it with PyRosetta. Okay. So like I said before, you won't have separate files, or you don't have to have separate files when you're defining your mover for PyRosetta, but you're going to have a very similar setup where you need to define your class, and that will inherit from the mover class. You could add a doc string. Rachel would encourage you to add a doc string. And then you'll define the necessary classes, or sorry, the necessary functions for your mover. So then how does your mover then get called in RosettaScripts? So we kind of talked about, and you guys should be a little bit more familiar with RosettaScripts from the last lab. So here, if we had the bootcamp mover, then we would call that in the mover section and then add that to our mover name. So here we have like temperature and number of loops in this bootcamp mover tag. So how do we read those in? And that's the parse my tag function that you'll define in your mover. So that's how you parse your XML tags. So this can be, you can have different parameters that you include in the parse my tag. And essentially this is going to go through and say, like, you know, if there's an option that is in loop, then set your class variable or your class data to that, you know, the option, what that option was set as, and the same thing for temperature. So this is just kind of what that will look like in Python. So if you're doing this in PyRosetta, the same idea applies. So you can have different inputs for your parse my tag, and that's going to go through, check if that option is set, and then set that to your variable. So you will need a mover, like a mover creator for your mover. So like we said, that's kind of how these can get loaded ahead of time by just that kind of connecting like the string that you're using in your Rosetta script to your actual mover in the C++ code or in your PyRosetta code. So these are all going to look very similar. They're pretty small or lightweight. So you'll have within your creator, you're going to have a create mover function that just, like it says, creates your mover. You're going to need this key name function that is connecting the string of the name of your mover and that string that you're using in your XML script to call it. And then the provide XML schema. So what do these look like? So for the key name function, that's going to call, so if you have within your mover, you're going to define your mover name. So then the key name function of your mover creator will call that mover name, or we'll call either mover name or get name to return that string to match those up. And then your creator function also has this create mover function, and when you define that, what it's going to look like is just creating a mover OP that is your mover. And then you have the provide XML schema, which is just calling a function in your mover that's also called provide XML schema. So for Python, what this is going to look like, so you have, once again, you're going to have your mover creator. It's going to inherit from the mover creator class. You'll need to have this instances variable that's a class variable there, and then your init function, so that's pretty standard. You'll have the create mover, the key name, and the provide XML schema, just like the C++ movers had. The key thing here is for the create mover, after you create your mover, so you have mover equals sample mover, then you need to append an instance of that mover to your instances list that you declared up here. All right, so what does the provide XML schema look like? So this is how you're essentially creating those tags and providing the information for those tags that you're going to use in the Rosetta scripts. So you'll have the different attributes. So this is an example of one that exists. So you'll have the name of that, like the string, what kind of type it is, and then a little description of what that is. And there's different kinds of attributes, so or there's different ways to create these attributes. So you can kind of look at those in the utility tag XML schema to see like if you want. So you can create like an attribute that has a default value. So if one isn't provided, then you say like, what is the default? So in this case, this final min is a Boolean, here's the description, and its default value is true. Or you can have attributes that are required. So there is no default because you are required to set that to something. So you go through and add these, and then you also have a definition to put on that will be provided of like what this mover does. So you have, you want to describe what your different parameters are that you can input into that tag, but then also like what the mover does in general. So that would be the XSD type definition with attributes. So for Python, this is going to look very similar. There is like this main difference where you have here you have an attribute list type that is your at list in this case. Looks slightly different in the PyRosetta. So instead of the attribute list, you're going to have list utility tag XML schema attribute underscore T. And then the rest of this is going to look very similar where you're listing your different attributes. So here we have a required attribute that we add that is the string for that attribute, what the type is, and then a description for that. And then once we create that, we append it back to our attribution list. And then if you have another attribution you want to add, this one is going to be an attribute with default. So you'll have to put the default value in there and then add that back. And then you're going to have, once again, the definition for the mover that you would want to appear for that documentation. And then how do we register then with the MoverFactory? So we're going to have, we're going to include your bootcamp mover creator in this in protocols init movercreators.hh. And then to register your mover creator with the MoverFactory, you'll add that to the init mover registrators.hh file. So you'll need to add your lines for your creator there. So now once you add those, then an instance of the bootcamp mover can be essentially requested using the MoverFactory with the string that matches the name of your mover. So how is this going to look with Rosetta? So you're going to need to define this list that essentially holds all of your mover creators. For your lab, you'll only have one mover, so it will end up just being one. So then you'll define a register function, and you'll get an instance of the MoverFactory. So if you guys remember, MoverFactory is a singleton, so we call getInstance instead of a typical constructor for that. Then you'll have your mover's creator, and then you'll register the creator with factory register. And then you'll want to also have your creator append that to the list of all of your mover creators for the program. And then you'll want to be sure that you call register before you parse an XML script that you call your, like in this case, the sample mover, or it won't recognize that that exists yet. Does that make sense? All right, so for lab 6, just a quick overview, you're going to create a new get branch. You're going to make this new mover subclass and then connect your mover to the MoverFactory, add your necessary private data members, and then hook your mover into RosettaScripts. And then you're actually going to run your mover in a RosettaScript. And then if you're doing this in C++, you can update your pilot app to use the job distributor, sorry, so that it calls in your mover. And even if you're working in Rosetta, so you'll get like a little taste of how you can essentially put like a long string of an XML script, and you'll call your mover within that XML script. So we don't do it in this lab, but you could add, you know, many other movers to that XML script and call that in Rosetta, which some people find useful to call Rosetta scripts inside of a Rosetta protocol.